Okay, students, we're going to take a look today at where we get radian measurement of angles. Let me start off by saying that you do not need to understand this explanation to do well on your tests or quizzes. I will not be testing you on this information, but I do just want to take about 10 to 15 minutes and quickly explain to you where we get radian measurement from. Okay, and so again, some of you will understand this really well, some of you will not, but I want to go over this explanation. The main thing you need to know how to do is to be able to convert radian measurement to degrees and degrees to radians, and also be able to work with radian measurements throughout these 3 chapters of trigonometry. So with that in mind, again, the explanation is not something you have to know, but take some really good notes on this and see if you can hopefully understand this. Keep in mind that measuring angles using radians is no different than measuring distance with kilometers instead of miles. Now, it takes a while to get used to, but once you understand the relationship or difference between miles and kilometers, then it's not difficult to use both units of measure. It's the same thing with radians. Once you understand the relationship or difference between degrees and radians, it's really not too difficult to use both units of measure. The first thing to understand is that 1 radian equals approximately or is approximately 57.3 degrees. So with that in mind, you really don't need to write this down. I'm going to explain later where we get this from, but 2 radians is approximately 114.6 degrees. Okay, and we're going to talk about where this comes from later. I just wanted to give you a little basis, a little foundation, so you can see the relationship or the comparison between 1 radian and degrees. So 1 radian is approximately 57.3 degrees. Another helpful thing to understand is that when you have a straight angle, which we measure that as 180 degrees, that would be the same thing as approximately 3.14 radians. And you know it's radians whenever there's no degree symbol like there is over here. Whenever there's no degree symbol right here, then it's automatically understood to be radians. So 180 degrees is approximately 3.14 radians. Okay, again, I'm just trying to give you a little foundation to see the comparison, and we're going to get into the explanation as to why actually right now. So let's go ahead and get into the explanation or the origination of where radian measurement came from. Please take some really good notes. Okay, what I want you to do is draw a circle in your notes and then go ahead and draw an angle that's approximately this measurement right here. Now, we're going to go ahead and say we have a radius of 1. That's very important. Please label that as 1. And we're going to label this radius here as a radius of 1. Now, what we've done is we've opened this angle up in such a way that the arc length on the circle right here also has a length of 1. That's very important. So what we have done is we have drawn an angle inside of a circle in such a way that we have a circle with a radius of 1, and the angle opening right here is opened in such a way that it intercepts an arc right here that also has a measurement of 1. Now, by the way, just so you know, I'm going to explain later where we get the angles from, okay, or the 57.3, but this would be 1 radian, and so this measurement right here would be 57.3. Okay, now again, I'm going to get into why later. Okay, so 57.3 degrees. Now, just kind of humor me, and you can watch or take some notes on this, whatever you want to do. If I continue this process around the circle, and I put another identical angle here, and another identical angle here, and another one, and another one here, and another one here, and another one here, and I did not mean for those to be there like that. Let me get rid of that quickly. Now, if I did that, notice what happened here, students. Please watch this, okay? How many radians do I have going around the circle? Well, here's 1 right here. Here's 1 right here. Here's 1. Here's 1. Here's 1. And here's 1 right here. And then we have a little one left over. Now again, if you don't understand what I'm doing here, that's okay. You're still going to do fine in the class, but all of these angles here would be 57.3, except of course for this last little sliver right here. Okay? Now, let me show you what's really cool about using a radius of 1. Please watch this carefully. Remember how you find the circumference of a circle? Circumference equals 2 pi r. Now, we know the radius for this circle is 1, so really where the radius is, I can put a 1. So now I have 2 pi times 1. So really the circumference of this circle is just 2 pi, correct? Sure it is. And 2 times pi, and we'll just say pi is 3.14, 2 times 3.14 is 6.28. So if I were to start right here and go all the way around this whole circle, the circumference would be 6.28. Okay? So think about this. Look at how many measurements I have here. I have 1, 2, 3, 4, 5, 6 units of measure. So this little space right here must be what? It must have a measurement from here to here of 0.28. So here's what I'm trying to show you. And again, some of you will see this and some of you will not. When you set up a circle that has a radius of 1 and you open up the angle in such a way that the intercepted arc right here has a length of 1 also, then you will have 6 of these angles that will go around the circle plus 0.28 more. And so that's where we get to 57.3. Let me say that again. We went around the circle 6.28 times. So if I take 360 degrees and I divide that by 6.28, what do you think you will get? 57.3. And so that's why each one of these angles here equals 57.3, except this angle right here. Let me grab a calculator real quick here. That angle there would equal approximately 16.04, this angle here. We'll just say 16 degrees. Okay? So now you're seeing we're calling this magical angle right here that has a radius of 1 and has an intercepted arc of 1, we're calling that 1 radian. And 1 radian equals 57.3 degrees. And so if you go all the way around the circle, then that's going to give you 360 degrees. Or you could also say this. Think about it, students. If 1 radian equals 57.3 and then 360 degrees, if you were to go all the way around the whole circle, 360 degrees would equal what? Wouldn't it be 6.28? Isn't that the entire circumference? Sure it is. So if I start here and go all the way around, that's 360 degrees. Or you could also say that's 6.28 radians. Let's cut the 360 in half, 180. And let's cut this in half. If 360 degrees equals 6.28 radians, then 180 degrees equals 3.14 radians. Okay? So that's pretty not easy to understand, like explaining it to someone, but I think you can kind of see where we're getting the 57.3 degrees from, okay? 360 divided by 6.28, because that's the whole circumference going around the circle. Now, let's go ahead and take this one step further, and I'll be done in about 5 minutes. And again, if you're a little lost, it's okay. I'm going to teach you in some future videos how to convert degrees to radians and radians to degrees in a very, very, very easy manner, okay, where if you're a little lost on this, you'll still be okay. All right. Now, go ahead. I'd like you to draw a circle in your notes, if you would, quickly, please. And then draw a vertical line and a horizontal line intersecting approximately in the center of the circle, like I'm trying to do right now. There we go. Now, here's what I want to show you. Remember, we said 360 degrees going all the way around is the same thing as approximately, I should put approximately 6.28. Now don't forget, 6.28, watch this students, is the same thing as what? 2 pi. So really, do you see that right here? 2 times pi is 6.28. So 2 pi is the same thing as 6.28, as is 6.28 is the same thing as 2 pi. So if I say 360 degrees equals 6.28 radians, if I wanted to write that in terms of pi, I could just say this. That's the exact same thing. I could say 360 degrees equals 2 pi radians. And look at this, 180 degrees equals approximately 3.14, and we know 3.14 is pi, so really you could say 180 degrees equals pi. So now listen to me, sometimes you want to write your radians with a decimal, and sometimes you'll want to write your radians using pi or in terms of pi. So with that in mind, again, tomorrow I'm going to teach you, or in the days ahead, I'm going to show you a much easier way to convert degrees to radians and radians to degrees. But for now, I want to show you very quickly where we get this from, okay? So if we were to travel all the way around the circle, that's 360 degrees, or 2 pi. Now, if we were to travel halfway around the circle like this, that's 180 degrees, or we can also call that what? Pi. So if I go from here to here, we call that pi, or 180 degrees. So if I were to go from here to here, that angle measures what? We all know that's what? 90 degrees. But you're also cutting pi in half. From here to here is pi. So if we cut pi in half, then we're getting, now please don't put 1/2 pi, okay? That would not be normal for trigonometry. We call that 1/2 pi is the same thing as just pi. That's a really attractive pi, isn't it? Let's change that. 90 degrees is the same thing as pi over 2. Do you see that okay? Now, listen, if we were to take pi over 2 and cut that in half, right here, we know that would be how many degrees? 45 degrees. And if you take 1/2 and cut it in half, you get 1/4, which would be pi over 4, or 1/4 pi, but really we put pi over 4. Now again, you might see this, you might not, but it's not too hard. I mean, just kind of take some notes here. So we know from here to here is 1/4, from here to here is 1/2. So what about this, students? If I were to go from here to here, you really should know that's 135 degrees. You really should, okay, because you went 90 plus 45 more. So 135 degrees. Well, think about it, students. This is 1/4 from here to here. This is 1/4 from here to here. This is 1/4 from here to here. So 1/4 and 1/4 and 1/4. Or you could say we have 1/2 a pi from here to here. So 1/2 a pi plus another 1/4 would be 3/4 pi. Or you could also say, and this is the right way to say it, 3 pi over 4. And we could continue this, students. We could put a line here, and we could say, let me change colors. We could say from here to here is 180 plus 45 more would be 225 degrees. But that would also be what? From here to here would be pi, and then we go 1/4 more. So that's like having 1 and 1/4 pi, which is the same thing as 5/4 pi, which is the same thing as 5 pi over 4. So I hope you're seeing what we're doing here. We're starting off with the premise that going all the way around is 360. So going 180 is pi. Let me say it again. Going all the way around is 2 pi radians. So going halfway around is pi. So going a quarter way around is pi over 2. And then we continue to divide the circle up. Now my time's just about up. I want to show you one more thing here. Look, going back to the premise here that I have 90 degrees right here. Well, look, if I were to take this and divide it up, divide that 90 degrees up into a third and a third and a third, you should know that you would have 30 degrees here and you would have 60 degrees here. Now this will be a little tougher to understand, but watch this carefully. Remember, 90 degrees is the same thing as pi over 2. So if I took 90 and divided it by 3, I would get 30. And thus this little angle here is 30, this little angle is 30, and this little angle is 30. Well, if I take pi over 2 and divide it by 3, watch this. pi over 2 divided by 3. Well, we know from previous math, divided by 3 is the same thing as times 1/3. Remember, when you're dividing fractions, you flip the second one and multiply. So pi over 2 divided by 3 is the same thing as pi over 2 times 1/3. You would get pi over 6. So if each one of these angles is 30, remember, you took 90 and divided it by 3. That gave you 30, 30, and 30. If you take pi over 2 and divide it by 3, you get pi over 6. So every time you move, how many degrees? 30, you're going another 1/6 pi, or pi over 6. Now, a lot of you got that, a lot of you did, and that's fine. Let me quickly finish this up. So if I go up 30 degrees, that would be the same thing as 1/6 pi. Now, if I go up 30 more degrees, that would be 60 degrees, which would be the same thing as pi over 6 plus pi over 6, or in other words, 1/6 plus 1/6, which is 2/6, which reduces to 1/3. So it would be the same thing as pi over 3, or 1/3 pi. Now, if I go another 30 degrees, we know that's 90, which of course would be pi over 2. Now, if I go another 30 degrees, that would be 120 degrees. And remember, each one of these little pieces of the pie here is pi over 6, or you could say 1/6 pi if that helps you. So I have 1/6, 1/6, 1/6, and 1/6. Well, if you take 1/6 plus 1/6 plus 1/6 plus 1/6, you will get 4/6, which reduces to 2/3, and 2/3 pi would be the same thing as 2 pi over 3. Let's do one more and then I'll be done, okay? Let's actually do two more. I'm going to add 30 more degrees, so now I have 150, and every time you add 30 more degrees, you're adding another pi over 6. So now I have 1, 2, 3, 4, 5, 5 1/6, and 5 times 1/6 is 5/6. So I would have 5 pi over 6, and then go 30 more degrees. That would be 180 degrees, and now I have 1, 2, 3, 4, 5, 6. So I have 6 1/6, and you should know that if you have 6 1/6, that equals a whole. That equals 1 pi 1. So 180 degrees equals 1 pi, or we really just say pi. Now, I went over a couple minutes, but this video is a really nice quick explanation of where radian measurement comes from and how it works in terms of decimals and in terms of pi. Some of you really got this, some of you did not. Remember, you will not be tested on this. I will not ask you to reiterate this to me. However, I will want you to be able to convert degrees to radians and radians to degrees, and I will teach you how to do that in a very easy manner later on. But I wanted you to get a picture of what radian measurement is all about.